Okay, in this class I'm going to just talk about maybe graphing some probability distributions through histograms and looking at a couple of very simple shapes. So I'm going to look at two experiments we've actually looked at before. The first one consists of rolling a single die once, and we can draw the probability distribution x versus the probability of x, and we look at all our possible values for x. To find the random variable, well, x equals the score on the upward face of the die, the score on the die. So the possible values for x are 1, 2, 3, 4, 5, and 6. There are no other possible values for x, and the probability of getting 1 is 1/6, and in fact the probability of getting any of these results is 1 in 6, assuming of course the dice is fair, and always if we add up all the probabilities we should get 1. So I want to think about this. I want to kind of construct a probability distribution and the histogram. I want to think about the histogram for this. So I might, up here I've got 1/6 on my vertical here. This is probability on this axis. Probability. And over here is the score on the die. So the scores could be 1, 2, 3, 4, 5, or 6. And a probability histogram just like this. It looks essentially like a bar chart, but I'm just going to put in a few bars along here. So my first bar is on 1, and it's going to be just go from there to there, and it's going up to 1/6. So that's my first bar that's showing the probability of scoring 1 is 1/6. And actually you'll see hopefully that every single bar is going to be the same. Probability of 3 is the same. These should all be equal height. A slight shake in my hand, so I'm not quite getting them perfect. And then so they're all equal heights. You can see each die score down here, 1, 2, 3, 4, 5, 6. They're my possible scores, and the probabilities of every one are 1/6. And one thing I want to just think about is this shape. And this shape doesn't change. It's the same height all the way across. We say this shape is uniform. We would say this is a uniform distribution. So this is a uniform shape. This is a uniform distribution. Okay. I want to look at another experiment. An experiment consists of counting the number of girls in a 3-child family, define a random variable, construct a probability distribution for the experiment, hence a histogram displaying the probabilities. So I might use a little tree diagram down here. If I look at the 3-child family, well, the first child could be a boy or a girl. The second child could be a boy or a girl. And we've gone through tree diagrams before, so I'm hoping you know how all this works. The third child could be a boy or a girl. So I'm kind of getting just a tree diagram is going to help me establish all my probabilities. Filling my probabilities into my tree diagram, which is always a good idea. The probability that my first child is a boy is 1 and 2. The probability my first child is a girl is 1 and 2. The probability that my second child is a boy, given that the first was a boy, is 1 and 2. The probability that a second child is a girl, given that the first is a boy, is 1 and 2. And hopefully you'll see that each of these things along the way is a half. And to find the probability of any particular event, you just multiply the probabilities along the branches. So the probability of a boy followed by a boy followed by a girl would be a half times a half times a half. Okay, so there are 8 possible outcomes. And let me write the probabilities of each one. So the probability of 3 boys is a half by a half by a half. It's an 1/8. The probability of boy boy girl is an 1/8. The probability of boy girl boy is an 1/8. The probability of boy, girl, girl is an 8. The probability of girl, boy, boy is an 8. And you'll see, hopefully, it's an 8 all the way across. Because to find the probability, you just multiply along the branches, a half by a half by a half. The experiment consists of counting the number of girls in a 3-child family. So I'm going to define my random variable as being x is the number of girls in a 3-child family. It's a bit squished in here, but I'm hoping you can read it okay. So if I draw my probability distribution for this, x and the probability of x, well, what are the possible numbers of girls in a 3-child family? Well, there could be 0 girls, or 1 girl, or 2 girls, or 3 girls. And the probability of these things, well, look at the probability of 0 girls. Well, that would mean all boys, so there's a 1 in 8 chance. The probability of 3 girls is girl, girl, girl. That's a half times a half times a half. That's also an 8. We have to be a little bit careful of these. Well, the probability that there's 1 girl, I'm just going to think about these, because there's 1 girl, boy, girl, boy, or boy, boy, girl. There's 1 girl in that. Boy, girl, boy. There's 1 girl there. Girl, boy, boy. There's 1 girl there. There are no others where there is 1 girl. So the probability that there's 1 girl, it's that 1/8 plus that 1/8 plus that 1/8. That's going to add up to 3/8. So there's a 3 in 8 chance that there will be exactly 1 girl in the house. I look at exactly 2 girls. So exactly 2 girls, well, it could be boy, girl, girl, or girl, boy, girl, or girl, girl, boy. Again, 1/8 plus 1/8 plus 1/8. That's 3/8. And if you add up all those probabilities, you should get 1. These numbers here, that's 1/8, that's 2/8, that's 3/8. 1/8 is 0.125. So I can put in the probabilities here. There's 0, 1, 2, and 3, and I can draw probability distribution for here. So I'm going to draw a probability distribution. I'm going to graph it. The probability that there are 0 girls, well, that was 1/8. The probability there was exactly 1 girl, well, that's 3/8. The probability that there was 2 girls is 2/8. And the probability that there was 3 girls is 1/8. Notice this distribution has a different shape. It's a different shape. But an important property of this is that it is symmetrical. So we would describe this as being a symmetrical distribution. Okay, most of the values are in the center and fewer on the outside. It's taller in the middle. I can draw something called a frequency polygon if I go from center of each bar to the center of the next bar. Something like that. And that's called my frequency polygon. If I do that, just kind of displays the shape of the thing. It's a symmetrical distribution. So those are 2 important different types of distribution. The first one is uniform, which by the way is also symmetrical, but this one very important, symmetrical, because we're going to be talking in our next class about a very particular kind of symmetrical distribution called a normal distribution, which kind of follows a pattern a bit like this, where it goes up and around like that. So in our next class we'll be talking about a distribution that looks like that, and that distribution has various properties, but let me just draw it because you're going to be getting familiar with this shape as you go on. That's my best picture. We're going to be talking about normal distributions in our next class. So Today we've just talked about symmetrical distributions and uniform distributions. Remember, every probability distribution can be graphed. Okay, and we're just looking, when we talk about the shape of the distribution, we're just talking about the shape of the histogram, the graph. Okay, so make sure you know those kind of definitions, those distributions, and what histograms are going into the next class. Okay, keep practicing.